Now in this video we are trying to find out the period. So period is a 1 over f frequency, so 1 over 50 equals to 0.02 second. So if we were to draw the graph of displacement against time, you'll notice that it is a sine graph. So this sine graph, the amplitude is 4 cm and the period is 0.02. So this is one full cycle. Okay, so we have this period, and this is my work. If you like my work, support me. So question 2, a wave of amplitude 5 cm is propagating with a wavelength of 2 cm. Sketch a graph of displacement against distance. Okay, so in this video you have displacement as a y-axis and distance as a x-axis. Now the amplitude is 5 cm on the y-axis and the wavelength 2 cm is on one full cycle, as you can see from the illustration. So you have 2 cm there. Okay. So our job is complete in drawing the graph. Do not forget to put a 0 here, I miss out, and label your graph accordingly. So how about B? Calculate the phase angle at a distance of 3 cm. Now there's this formula that you might not have seen before, but I'll explain to you why we use this. What is this about? Now the ratio of length angle is equal to the ratio of the length. Alright, so you have phi over 2 pi and x over lambda. 2 pi and lambda, 2 pi represents the angle after one cycle, 360 degree, and lambda represent the one cycle of length. So the corresponding any value of angle is phi or theta if you want to use that, and the length is any length of x. So we use this all the time. Ratio of angle equals to ratio of length. So this one means one cycle and this two means any value. Alright, so back to this, we can calculate the phase angle at distance of 3 cm. So 3 divided by 2 times 2 pi, you get 3 pi. 3 pi radian actually. Alright, so to illustrate further, now if I were to draw the graph again, so it's 2 cm and 3 cm is around here, but I want to rub off the 2 cm and 3 cm. Basically I want to put here as pi, 2 pi and 3 pi. This is sine graph, so it's actually here. Next question. The displacement y of a particle oscillating given as y equals to 6 sine 4 pi t. 6 is the amplitude and 4 pi is the omega, angular frequency. Alright, so omega can be also 2 pi f, that's a general expression, but in this case I can find out that the omega is actually 4 pi. And if you want to find the frequency, so you just equate the 2 pi f equals to 4 pi, so you have f equals to 2 hertz. Now if you want to find the period of the oscillation, so you have period equals to 1 over f, 1 over 2 equals to 0.5 second. And the next thing is they want you to sketch a graph of displacement against time for the oscillation. So y equals to x, y cm, displacement, and t second. So you have your amplitude 6 and your time 0.5. That's the two information that we need. So I draw. Normally I just draw 1.5 cycle, 6 and 0.5, and I can draw write 0.25 as well. The best is if you can write 0.50. So you have this graph and your job done. Question 4. The wave of wavelength 5 cm lambda 5 is oscillating in a vertical plane as shown. 4 cm is the amplitude, as you can see from the graph. Lambda is different. Lambda is the length of one cycle wave. 5 cm. Amplitude is 4 cm. And the period is shown as 0.4 second. So if they want angular velocity is also omega. Omega is 2 pi over t, 2 pi over period, so 0.4. Then you have the answer of 5 pi radian per second. And then you need to know what is the wave number. Wave number is k. K equals to 2 pi over lambda. Alright. So 2 pi over lambda, pi over 5. So you get the value of 1.26. And the unit is cm-1. Next thing is they want to write an expression for the displacement of the wave in terms of time. So you have y equals to 4. If you are not sure, you can turn back to find out. The amplitude is 4 cm. 5 pi is the omega. So that's the complete answer. You can double check. You need 4 for the amplitude, 5 pi for the angular velocity. So you have this. Now the last one, determine the phase angle of the particle that is oscillating at a distance of 4 cm. So you have this and that. So you put in 4 divided by 5 times 2 pi. So your final answer will be the phase angle of 1.6 pi radian. That's all. Thank you.